Okay, for list of content, first we have logical equivalent. For logical equivalent, we want to know the two table equivalent or not equivalent. We have tautology, contradiction, and contingency. We want to know that the two table is tautology or contradiction or contingency. And we have conditional, inverse, converse, and contrapositive. Last but not least, we have conclusion.
First of all, for the introduction, I will give the definition of logically equivalence. The statement P and Q are said to be logically equivalent and we write P biconditional to Q. That is when the statement P is true, uh, respectively false, if and only if the statement Q is true, that is respectively false also. So next, proving the proposition whether it is logically equivalent or not. So when the proposition is equivalent, for example, prove that not P and Q and not P or not Q are logically equivalent. So when we observe the truth table for the column not P and Q and not P or not Q are identical. So we can conclude that not P and Q and not P or not Q are logically equivalent. So next, for the proposition that is not equivalent, for example, determine whether if not P then not Q and if P then Q and if Q then P are logically equivalent or not. Since the truth table for the column P if not P then not Q and if P then Q and if Q then P are not identical, we can conclude that if not P then not Q are not logically equivalent to if P then Q and if Q then P.
So we already know the difference about the equivalent or not equivalent, right? So we look at the tautology. What's the definition of tautology? Tautology is a propositional statement that is true under any possible true-false valuation of its propositional variable. Or easy to say, right? When we get all the true value are true, so it's a tautology. For example, the question say that show that P conjunction Q disjunction negation P disjunction negation Q is tautology or not. For how to draw the table, we use the formula n power of 2. And here is unknown. Unknown here we have PQ, we have 2. So we use the formula 2 power of 2 we get 4. So we have 4 column, right? So for P, we write true false false, Q true false. Negation P otherwise to P, we get false true. Negation Q same, false true. P conjunction Q we get true false. Negation P disjunction Q we get false true. So for P conjunction Q, disjunction negation P, disjunction negation Q, we get true. Since P conjunction Q, disjunction negation P, disjunction negation Q are all true, therefore the proposition is tautology. So we already know, right, what is tautology. Now we look at contradiction. What's a definition of contradiction? Contradiction is a proposition that is always false, whatever the true value of the component statement are. Or we can say that when we get all the value are false, so that it contradiction. For example, we look the question, show that P disjunction Q conjunction negation P conjunction negation Q is contradiction or not. For this conjunction, for this contradiction, we use same formula to draw the table and power of 2. And here is unknown. We get PQ same like tautology. We have 4. So for P, we write true, true, false, false. For Q, true, false, true, false. For negation P, false, false, true, true. For negation Q, false, true, false, true. P conjunction P disjunction Q, we get true, 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 false. Negation P conjunction negation Q, we get false, 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 true. So for P disjunction Q conjunction negation P conjunction negation Q, we get all false. Since P disjunction Q, the conjunction negation P conjunction negation Q are all false, therefore the proposition is contradiction.
Contingency. What is contingency? Contingency is a proposition when the truth value contains both true and false. Now let's look at the questions. The question asks to show that P disjunction negation P disjunction Q is contingency or not. The first step is to find the value of P and Q by using the formula to the power of n. Then we got fourth row because there is only two subject which is P and Q. After finding the truth value for P and Q, we need to find the truth value for P disjunction Q. As we already know, disjunction is equal to plus, truth value equal to 1 and false equal to 0. Hence, we can find the value of P disjunction Q. In the row 1, P and Q are both true, so it will be equal to true plus equal it will be equal to 1 plus 1, and we will got the answer is true. The second row is true plus 4 false are equal to 1 plus 0, and we will still get true. The same goes as the third row, which is false plus true equal to true, and the final row is false plus false equal to false. Next is to find the negation of P disjunction Q. As we already know, negation is equal to negative or inverse. So inverse of P disjunction Q is false, which means if P disjunction Q true, then negation P disjunction Q is false. So from the previous value of P disjunction Q, we just need to inverse their value and we got false, 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 and true. The final step is to find P disjunction negation P disjunction Q. True plus false equal to true, true plus false still equal to true, and false plus false is false. The final one is false plus true is true. From the final answer, we can conclude that P disjunction negation P disjunction Q contain both true and false. Therefore, the proposition is contingency. Logically equivalent. Logically equivalent contain conditional, inverse, converse, and contrapositive. Conditional is always changed because it was based on questions, while the other three, which is inverse, converse, and contrapositive, are related to conditional. The first one is inverse. For inverse, we just need to put negative, I mean negations on the both side, because inverse is most likely like negative of conditional. So the answer will become negation P, negation Q. For converse, we just need to swap both values. So it was more likely the back one will be put on the front and the front one will be put on the back. The final one is contrapositive. Contrapositive is a combined process between converse and inverse. So to get contrapositive, we just need to converse the conditional and inverse the result, and we will get contrapositive as the final answer. This is the truth table that show both converse, inverse, conditional, and contrapositive are related. By using the formula that we know, we will find the P implication Q, negation P implication negation Q, Q implication P, and negative negation Q implication negation P. As the table shown, we already know that P implication Q is the conditional. So from the table, we can conclude that actually the conditional and contrapositive are more likely the same because both of them have the same value, while the converse and inverse are the otherwise. The both of them have the same value. So why actually contrapositive have the same value as conditional? It is because contrapositive actually undergo both converse and inverse. So from the conditional, we try to converse the conditional and we got true, true, false, and true, which is it was almost the same as inverse. And then when we think about it, converse and inverse are actually the same. And then more likely that contrapositive actually undergo two times of inverse. So that's why the proof values we got the same as the conditional. This is example of the question for conditional, inverse, contrapositive, and converse. The first one is conditional. So the statement is P, the P is called the final goal, and Q, the P is the football champions. By using implication, we got P implication Q, and the words is if Luffy score the final goal, then Luffy is the football champions. Next is how to get inverse. As I already told you that inverse is most likely like we put negation for both sides and we will get negation P implication negation Q. So why we use P negation Q? Well, it was because it was the conditional. Then for the words we will get if Luffy not score the final goal, then Luffy is not the football champions. Next is converse. We'll still use the same conditional which is P implication Q by using the formula that I mentioned before. Converse is just a swap in a statement, which is if a P are on the back, we put it on the front, and if Q are on the front, we put it on the back. So just swap both statements. So when we are swap P implication of Q, when we do the converse, we will get Q implication P. And the words will be if Luffy is the football champions, then Luffy score the final goal. The last one is contrapositive. After using after finding converse and inverse, we just need to apply both result and we will got the contrapositive. The first one is using the converse, which is Q application P. And then we try to inverse the converse and we will get negation Q implication negation P. And that's the answer. That's how we got contrapositive. The words will become if Luffy is not the football champions, then Luffy scored the final goal.
Okay, for conclusion, In logical equivalent, we will be able to construct the truth table and determine the logical equivalent. We can differentiate between conditional, inverse, converse, and contrapositive. And last but not least, in logical equivalent, we can apply in many different situations in our daily life.